All right, so today we're going to talk about making decisions. And so we were typing in, some basic things, like we were taking in data from the user and we were using that data, saving it in a variable, and we were doing equations and we were displaying the data, the results from the equations. But the computer didn't make any decisions. It just did calculations so far. So now we need the computer to start making some decisions for us. So this is where it starts getting really interesting. Okay, so we're going to talk about something called relational operators. You've probably seen these before in math. Hopefully you know what greater than, less than is. And so just try and, you can always look back at the chart, but try and remember, if you can envision this is silly, but if you can envision this as a mouth here with like a little circle around it as a face, the greater than one, always think like Pac-Man eats the greater number, if that helps you. Or you can just look at the chart here, but the opening goes towards the bigger number. That's the greater than. So greater than, less than. Now, something that you may not think about as much is if you have to do greater than equal to or less than equal to, you put the equal sign in there. You have to make sure that the greater than sign comes first and then the equals, or the less than sign, then the equals. Because if you switch them around and you put the equal sign first, C++ won't allow that. And it also doesn't want a space between the two symbols. So you have to make sure that there's no space between these two symbols. So what it means is, let's say you were looking for a house and you said, I'm looking for a house that's under $200,000. Well, then you would use less than. But if you found a house came up that was $200,000, it wouldn't be in your search criteria if you said less than. But if you say less than equal to, a house that was 200,000 would come up in that search criteria. So you have to decide if you actually want to include that number or not include that number in your actual search. Okay. So you can search to see if something is equal to, but instead of using one equals, I know that seems strange, you're going to put equals equals. And the reason is because if you use one equal sign, that means to assign a value to a variable instead of actually making it equal. Okay, so I wanted to show you something here. Okay. And I wanted to get a new. Okay, so if you were to say x equals 5, right, like that, that means to assign x the value of 5. That's called assignment. But if you were to say x equal 5, that means is x equal to 5? So there's a difference. And you have to make sure when you do the equals, you don't put a space between the two equal signs when you do it. So 2 equals means, is it equal? That's a question. And 1 equals means make it equal, assign it the value. So when you're asking questions, if you do equals with 1 equals, that's not a question. Okay. And then you do, if you want to check to see if something's not equal to something, you can ask that by putting an exclamation point equals. And that's called a negation operator. That exclamation point, it just means the opposite of. So the opposite of equals means not equals. Okay. So when you do your expressions, they're going to evaluate to true or false. Okay. So if we were looking at these examples, 12 is greater than 5 is true. 7 is less than or equal to 5 is false. This would be true if this was 5. So this example here, if this was 5 is less than equal to 5, that would be true. I just wanted to tell you that because when you put the equals, it actually includes that number. So it's actually saying less than or equal to. And then x is equal to 10. If x is 10 up here, that's true. X is not equal to 8. Well, if x is 10, x is not equal to 8 is true. And then x is equal to 8 is false because x is 10. Does that make sense to everybody? So far, so good?
Yeah.
Okay, perfect. All right, so if you want to, you can actually do an expression over here, a Boolean expression. You can say x is less than equal to y, and if that's true, then it'll actually save the result over here. If it's false, it'll actually save a 0, and if it's true, it'll save a 1. So 1 is true and 0 is false. Okay. So we are going to use something called the if statement. And so you can think of it like if it's raining outside, take an umbrella. Okay. But you don't have to do anything if it's not raining in that particular case, right? If it's cold outside, wear a coat. Okay, so just some basic things. We're not talking about what if it's not cold, but we're just talking about what if it is, or what if it is raining. So we use this diagram called a flow chart, and a flow chart has a diamond for decisions. So any type of question that you have, any type of decision, you use the diamond. And so is it cold is a question, that's a decision. And so if that's true, then you follow the arrow for yes. So wear a coat is what you do. And if it's not, you follow no, and you move on to the next thing in your flow chart. Okay, so you skip that one. Okay, everybody good so far? So far, so good. Okay. So you can do more than one thing if it's cold outside, though. You don't have to just wear a coat. You can wear a hat and wear gloves. And so your if can have more than one statement inside of it. And so you can put more than one thing inside of there. And then still, if it's not cold, then you just skip and move on to the next thing. Okay. So you have if, and then you have some sort of expression, something that's going to evaluate if it's true or false. Okay. And then you have your statement, and you can have multiple statements if you want to. Okay. If your if is false, then it skips whatever the statement is here. And if the if is true, then it does what the statement is. Okay. So this example has 3 scores and an average variable. And what happens is you're going to enter 3 scores. So it takes the first score into score 1, the second score 2, and the third score 3. And then it's going to add those 3 scores together, divide by 3, so you can get the average. They put 3.0 so that you actually get the decimal number when you do the division. And then it's going to print out the average. Well, if the average is greater than 95, then we want to say congratulations, that's a high score. So here, this if says if, and it tests the average variable, what variable are you working with, greater than 95, then it says congratulations. Now, if it was 95, it wouldn't say that because it doesn't say equal to. It doesn't say greater than equal to 95, it just says greater than. So 95 would not be included in this congratulations. It has to be greater than. And if it's not greater than, then it won't say that. It won't say this statement. So your if automatically gets one statement that goes with it. So line 21 has line 22 associated with it. That's the statement that goes with it. If you put more statements, though, we have to put curly braces. So I'll show you what that looks like in just a bit. But you get one statement. Now, you should indent line 22 because it's part of the if. So whenever you do an if, whatever is included with the if should be indented. Now, would it work if you don't? Yes. But is it hard to read? Yes. So you should indent it to show people this statement actually is going to be inside of this if. It's going to happen if the if is true, and it's not going to happen if the if is false. Okay, so you can see you enter the 3 scores and the average is 80. Okay, so it doesn't say anything. But then when you average these 3 scores of 100, you get 100 and it says, congratulations, that's a high score. Does anybody have any questions so far? Okay. All right, so this is the flow chart for that. It says if average is greater than high score, then we're going to display congratulations, that's a high score. Otherwise, we're going to move on with the next thing. Okay. So one thing you have to be careful of is when you're doing your if, you don't put a semicolon after the actual expression that you're doing here. So when you do if, for example, score is greater than or equal to 90, don't put a semicolon here at the end of this. If you put a semicolon, it actually just skips this line and it's no longer an if, it just ignores it. And then the next line always happens. It doesn't actually happen with the expression. It happens all the time. So you don't want to put a semicolon after your if expression here. So this line shouldn't get a semicolon, just the statement that goes with it underneath. Okay. And then also be careful if you're asking if something is equal to with floats and doubles, because remember that there's quite a few digits of precision there. And so it might be off when it does that. And so when it returns something, it'll return 0 for false and any other value would be true. So I was talking about this a bit. If you're going to have more than one statement going with the if statement, then you need to have curly braces. Okay. And some people like to put this curly brace up on the same line as the if, and that's okay. I do that a lot. Or you can put it down here lined up with the if, but you need a curly brace to start and a curly brace to end. And this is called a block of code. Anytime you put curly braces and you include code inside of it, that's called a block of code. So your if is here. And if this is true, If this expression is true, then what's in the block of code here from this curly brace to this curly brace will get executed. Okay. Now, if you didn't include the curly braces here, then only this grade equals A would get executed. This as part of the if, this would get executed all the time because it wouldn't be part of the if. And so it only includes one line with the if by default. If you want more than one line to be included with the if, then you need to put curly braces around it. If you want to put curly braces for every if you have, just to be sure, and you only have one line, that's fine. Because as soon as you add a second statement, then you need to have those curly braces. Because anything, if you put one line and you don't have curly braces and then you add another statement, then what's going to happen is it's not going to be included as part of your if. It's going to happen all the time. So this is a common error that people have. So some people like to put curly braces around everything just in case. Okay. So next we have something called the if else statement. So with the if else, you can say if this is true, then we're going to do this. Otherwise, the else will happen. So what do we do if it's not true? And so we do this expression, and if it's true, then we do the statement. If it's false, then we do the statement 2. So the else doesn't have an expression with it, and that's because it's a default to happen if the if doesn't happen. So it doesn't get a state, it doesn't get an expression, and it doesn't even get the parentheses with it. It just says else, and then whatever underneath you want to do, whatever statement you want to do. Okay. So in this particular example, it's going to have you enter an integer, and whatever you enter, it's going to determine if it's even or odd. So it's going to take in this number, saves it in a variable called number, and then it's going to check to see if that number, when you take that number divided by 2, you get the remainder. And if the remainder is equal to 0, then the number is even. So if you were to take a number and divide it and not have a remainder, that's what that's saying, then you know that number is even. Okay. But if you have a remainder, that would be your else. That would tell you the number is odd. So for example, in the output, you see that you do 17 as the input and 17 is odd for output. So the if test to see if you divide it by 2 and you don't get a remainder, that's what that expression is saying, then that number is even. Otherwise, the else would happen and the number would be odd. So when you have an if else, if the if happens, then the else will never happen. And if the if doesn't happen, then the else automatically happens. So if you have an if else, one of them has to happen, either the if it's true, or the else if it's false. Does that make sense to everybody? We have questions about that code? Okay. Let me know if I'm going too fast, please. All right, so here's what it looks like when you're doing it. Here's the question. If number divided by 2 and get the remainder, this means remainder equals 0. That means if you divide it and there's no remainder, if that's false, then the number is odd. If that's true, the number is even. Okay, and then both ways actually go down here to whatever's next in your diagram. Okay, another example. So if you have 3 variables, one called number 1, number 2, and quotient, and you know that it's not good to divide by 0. That's always been a problem. And so one thing you can do is you can actually have an if statement that says if number 2, because number 2 is the one that's a problem. When you take number 1 divided by number 2, if number 2 is 0, then you always have a problem when you're dividing. So if number 2 equals 0, then it tells you that division by 0 is not possible. And then it has you enter another number, but this one actually doesn't do the CN to enter another number. It just has you run it again. We'll talk about in the future a loop to repeat the program to have it do it again. But the one thing about this is the if else doesn't repeat. So it's only one time. So you could technically ask them to re-enter it and do a CN there. But if they do it wrong again, it won't repeat and have them do it again. And so we're going to talk about looping, which is repeating. And at that point, we'll have it just loop until they get it right. But at this point, we can only have them do it again if they get it wrong the one time, but it won't repeat to have them keep re-entering it. So I guess it's a choice. If you wanted to, you can have them enter it here, but it's only going to happen the one time. Okay. Now, if you do this if they enter it, the way that it's written and the else, it won't make it to the else. So you'd have to rewrite this code if you wanted to do that, because the only way it gets to division is when it gets to the else. So if it executes the if, and you were to take in the line here again, then it wouldn't divide them unless you actually put that code in there, because it wouldn't make it to the else. So you'd have to rewrite this code to get that to work. And it won't repeat if they do it wrong a second time or a third time. So we'll learn about that in the future. But for this particular program, the only thing it does is if the number 2 is 0, it tells you that that's not possible, run the program again. And then if it's not, then it goes ahead and divides them and gives you the answer. Okay, so you have to run the program to get it to work if you did it wrong the first time. Okay, ready with me? We'll learn how to make that better in the future so that we don't have to run the program again to get it to work. But we don't have enough yet to do that. Okay, so sometimes we have nested if statements where we can do more than one condition. I like to say that my life is like a bunch of nested if statements. So like, if this happens, if this happens, if this happens, then I'll do this. But, you know, I feel like that a lot of times where, you know, I'm playing this game, if this happens and this happens and this happens. So it could look something like this as an example. So if you're employed, and the Y stands for yes. So if you're employed, that's true. And then this one too, if you're a recent graduate, if that's yes as well, then you qualify for a special interest rate. But if you're not a recent graduate, then you must have graduated from a college in the past 2 years to qualify. It'll say that. Or if you're not employed, it'll say you must be employed to qualify. So you have to get both of these to be true in order to qualify for the special interest rate. So you have an if, and then you have an if inside of there. And if both of those ifs are true, then this one happens. And if this one's false, this one happens. And if this one's false, this one happens. That makes sense so far? Okay. All right, so it looks like this. So if employed equals yes, and then here's the nested if. And you don't have to indent it as far as C++ is concerned for it to work, but you should indent it for readability. When people are looking at your code, indentation helps them read it. So indenting this if inside of this if helps you know that this is nested inside of here, that they're not completely separate. So this one is inside of here. So you indent it so you can see that, and you can put the curly braces so that this if includes all of this, and includes from this curly brace to this curly brace, and these get lined up. And then these curly braces get lined up with this if, and you have to put these 2 curly braces if you're going to have more than one statement. Okay, so if you have 2 cout statements, then you're going to need the 2 curly braces. Okay, so this if is inside of this if. All right, so here's an example of the nested ifs again. So here's the if inside of the if. I think I'm getting a cougar alert. I'll check that in just a bit. So there's an if inside of an if, and then this else, you have to be careful with the else's, because this is why indentation is very important. Because if this if is true, then we're going to get inside here to this if and else. If this is true, then this will happen. But if this is false, then this else will happen, the one that's lined up with it. But if this first if is false, then we're going to jump to this else down here. And so it's important that you have things indented and you have the curly braces, so you can tell that this curly brace on line 22 and the one on line 34, all of this is inside of that if. So the only way to get to this code from line 23 to line 33 is to get true for the line 21. Okay, if you're true, then you get inside there and you do this if and else. If you're false, then you jump down to the else on line 35 where you're not employed. And then you do what's inside of this else on line 37. Okay, so you could push everything over there and not indent it, but then it makes it very hard for people to read, for them to know what is included inside of what. So it kind of is a headache when you don't indent correctly. So when you're doing it, whatever editor you're using, whether you're using Online GDB or C++, Shell, or you're using Visual Studio, whenever you put your if and you hit enter with your curly braces, it should automatically indent for you. So make sure you leave that indentation so that other people can read your code, because it makes it hard to read when there's no indentation. So if something is included inside an if that's supposed to happen when it's true, then it should get indented. And if there's more than one statement, more than one thing you're doing inside that if, then you need to put curly braces around a starting curly brace and an ending curly brace to include all of that inside of there. It's probably good practice to just put the curly braces if you're not sure, and that way you don't leave something off. Okay, does anybody have questions about this code? Okay, so you can see here a breakdown that this if and this else go together. And then you can see that this if and this else that are nested inside of the if go together. So we call that nested whenever something is inside of something else. So just think like nested eggs. If you've ever gotten those nested eggs, it's an egg inside an egg, inside an egg, inside an egg. You keep opening up the egg to see another egg. So that's what this is showing you, is nested is one inside the other. Okay. All right. So sometimes we have more than one thing we want to do. So example, if it's raining outside, take an umbrella. Else, if it's windy, take a hat. Else, take sunglasses. So you have more than one option before you get to the default option. And so we call this else if. Okay. So what happens is you start with an if. Your conditionals always start with an if, and then you do an else if you have something else that you want, another option that you want to add. And so else if is actually 2 words, it's all lowercase, and then it does have an expression because it's another option, and it may or may not be true, okay? And so the only way to get to the else if is if the if is false. It won't go to the else if the if is true, it'll do the if, okay? So they are all connected when you do this. If you do separate if statements that aren't nested inside each other, they're just separate, then they're all separate and they can all match or all not match. So you can do if, and if it's true, it happens. If it's true, it happens. If it's true. But when you do if, else if, they're connected. And so when you do the if the if is true, then you're going to do the statement. But if the if is false, then you go on to evaluate the else if to see if it's true. Okay. And so when you do else if and if, they're connected. But when you do if, they're not connected unless you nest them inside of each other with the curly braces. So you notice that the else if has an expression because it's another option that may or may not happen. If you want to put an else at the end, you can do that without the expression, and that gives you a default. The difference between having if, else if, else if, else if, else if, and not having an else means that none of them have to happen, because if they're all false, none of them will happen. But when you put an else at the end, you're saying that if none of these happen, the else has to happen. That's a default. But if you do else if, then it doesn't have to happen if it's false, because there's an expression. And the if and the else if only happen if the expression is true. Whereas the else happens if none of the other ones happened. You can have as many else ifs as you want. Okay. You don't have to have any, you can have 1, you can have 2, 3, 4, and you don't have to have the else on the end unless you need it or want it. Okay. Is everybody with me? Anybody have questions? Okay. So we have an example here. So we have if test score is greater than or equal to whatever you have for A score. So this, whenever you do these capital letters like that, that's a constant. And so constant means that it's not going to change, and that's a value that you have that you're going to set as your variable. So like A score might be 90 for your, and B score might be 80, and C score might be 70, and D score might be 60. It's whatever you have for your, you could set it higher, like an A is from 95 to 100, but that would be what your starting A start at. That would be what you set that variable to. So test score is greater than or equal to A score. We'll say the A score is 90. So if you get greater than or equal to 90, then it'll say your grade is an A. Okay. And then otherwise, if you get greater than a B, we'll say that's 80, then your grade is a B. Greater than a C, we'll say that's 70, then your grade is a C. And then if you get greater than 60, you get a D. So if you don't have any of these are true, if none of these are true, then automatically you get an F. So if you don't get an A, B, C, or D, then you automatically get an F. So see how there's no condition on this one. That's not an else if. You could write it as an else if greater than equal to F score if you had an F score. And then if it didn't match any of those, if it was invalid, then it wouldn't say anything. Okay. But if some people like to make their else an invalid statement in case, somebody enters something that's out of range. Let's say they enter like a -10, and that shouldn't be an F because you shouldn't get negative grades. So you could always write this as an else if with having this a condition that matches F's, and then do an else for invalid. So that's another way to do it. So there's multiple ways to do this. And so you have to think about which way makes the most sense for you, but just make sure that you're covering everything. So for example, if 90 is included in your A score, let's say A score is 90, then make sure you do greater than equal to, because if you just do greater than, it won't include A score. So make sure that all of the values are covered, because if you're just doing greater than, you're not doing equal to for some of them, then you might be skipping some values. So make sure you're covering everything. But you do as many else ifs as you need. And then you can, or, it's optional if you want to put an else at the end and if it works with your situation. Okay. And see how none of these ifs or else have semicolons after the actual evaluation here. So in line 22, you don't have a semicolon. Line 24, if you put a semicolon, it messes everything up and you would actually get an error, because if I were to put a semicolon on line 22, we'll practice this more next week. What'll happen is this statement will happen automatically for everything, and then it'll say that you have an else if without an if, because they're not connected anymore, because you put the semicolon in there. And so it messes everything up. So be careful of that when you're doing that. Okay. So I was just talking about this. It's possible to also, you don't want to include negative scores, for example. So you put an else at the end. So this else if does grade F, and then else this one does invalid test scores. If you got a negative, then it would go into the invalid. Anybody have any questions? Okay, you can use flags, and we call a bool variable something that evaluates to true or false. So 0 is false and anything other than 0 is true. So you can set flag variables to see if something happened. Like you can do an if statement and see, if this is true, and then what do you want to do in a certain situation? So you can say that maybe that's an error or that's invalid. Okay, we can get more complicated with our statements. So we can use and, or, and not. So and is the ampersand, so it's easy to remember. And you get 2 ampersands. So and is easy for people to remember when they think about everyday life. So if you were to think about if, I were to say to you, you have to do the assignment and the quiz. Well, and means that you have to do both. It doesn't mean one or the other. It means both. So you're not going to do well in the class if you just do one, because I said that you have to do both. You have to do this and that. So that means both. And I think everybody understands that when you're talking and someone says and, that means you have to do both. Okay, so both of them have to be true. Both sides have to be true in order for it to be true if you do and. Or means only one side has to be true for it to work. So if I said you can do the assignment or the quiz, that means you have the option of doing one or the other. If you wanted to do both, of course, that wouldn't be a problem either. You could do both, but for an or, you only have to do one. So if you did the assignment, you could say, oh, I don't want to do the quiz, or you could do the quiz and not the assignment, or you could do both. And they would be true if you did any of those combinations. Okay, the or is a little bit harder for people to remember. It's a straight up and down line. So it's actually, if you do shift and the key above the enter, then you can get that symbol. It doesn't look like a line on some keyboards, but it is a straight up and down line. And you don't want to put spaces in between the ands and the straight up and down lines. Okay, and then if you want to reverse any situation, you just put the exclamation point, and that means to negate it or to take the opposite of it. It means not. Okay. So if you're looking at these examples and you would say X is less than Y and Y is less than Z. Okay, so you have to have this side be true and this side be true. So X is 12 and Y is 5. So 12 is greater than 5. That's true. Okay, so what about the other side? Y is greater than Z. So Y is 5 and Z is -4. So 5 is greater than -4. That's true. So this side is true and this side is true. So this whole expression evaluates to true. What about this one? X is greater than Y. So 12 is greater than 5. True. Okay. Z is greater than Y. Z is -4, greater than 5. That's not true. So this is false. So this one is true and this side is false. Because one is true and one is false and you have an and, that becomes false. So the answer is false. What about with or? X,
Professor,
yes.
Colin closed the campus for today and tomorrow.
Yes, I saw that and I was going to mention that. So if you have classes, then you can do, I don't know if your teachers will be posting anything for you to work on to make sure that you're still on track. See, part of it is we still have to cover the same amount of material and it makes it hard whenever they close, right? So that's why I'm hoping that by just going through this, we can still keep moving with the chapters. And it doesn't affect us too much because this isn't as much I really want to make sure that you read the chapter and you watch this, and hopefully if you have some questions, those of you that are here, you can ask as we go through it, but those that are watching this video back a second time or for the first time, you can write down your questions and we can go over them next week. Hopefully everything will be cleared up, right? And we'll meet next week, and then that way we can finish covering chapter 4, just because I don't want to get too far behind. But yes, thank you for letting me know that. So if you do have classes, please check Canvas for what your instructors are asking you to do for the time that you would have been in class today and tomorrow. Because I saw that my phone was buzzing too. Thank you. So I know, crazy weather, right?
Yeah, you're welcome.
Thank you. Yes, I was wondering what I had to do because I have a class at 11 and I was wondering if I had to drive out there because it was a 2-hour delay. And I had to make sure that I finished this in order to go out there. So it's an interesting day, but I am recording this, so I will post it. So just make sure that you do go over chapter 4, because next week we're going to actually start coding with it and practicing with it. And I want to make sure everybody's had a chance to look at it. So yes, thank you. Thank you for letting me know, and thank you for being here. And if you're watching the video, thank you for taking the time to watch it. So, all right. So X is less than equal to Z. So X is 12 and Z is -4. So 12 is not less than or equal to -4. So that's false. But what about this side? Y is equal to Z. So Y is 5 and Z is -4. So they're not equal. So that's false as well. So if you have two falses, even though we have an or, because neither one of them is true, then this one evaluates to false as well. So what this one, X is less than equal to Z. So X is 12, Z is -4. So yes. Oh wait, 12 is less than, okay. So 12 is not less than equal to -4. That's false. 12 is not less than equal to -4, but this side, Y, which is 5, and Z, which is -4, 5 is not equal to -4. That's true. So this side's true, but this side is false. So if you have a false or a true, then that still becomes true because only one of them has to be true. So even though this side's false, this side's true. So that becomes true. X is 12 is greater than equal to -4. That's true. But then when you put the exclamation point in front of it, it becomes false. So even though this evaluates to true, as soon as you put the exclamation point in front of it, you switch it to false. So it's true, then you switch it, it becomes false. Does that make sense to everybody? Okay. All right.
Professor,
Yes.
back on that, why does the exclamation point make it a false statement
So
on the last one?
yes. So that's what that exclamation point does. It's called the negation operator, and it stands for not. So it just actually flips everything. So if you put that in front of like something you have with parentheses, whatever is in parentheses, whatever it evaluates to, if it evaluates to true, it flips it and becomes the opposite. And so if it was false, it would flip it to true. And if it's true, it flips it to false. So it just flips to the opposite. Sometimes it's hard to think of when you would use that, but the best example I would think is I like to do a guessing game with my students as an example. And the guessing game, whenever we get to loops, you want the user to keep guessing as long as they don't guess the right number, right? So a lot of times we think of things like, we want to continue as long as it's true. Well, that's, yes, sometimes, but then sometimes we want to continue something or do something when it's not true. And so you actually flip it. So you'd say like, I want to continue this game as long as it's not true, as long as they don't guess it correctly. So sometimes you want to use that negation to say when it's not true. And I know it seems kind of strange to think about, but sometimes, or we want the user to keep entering the data as long as they're not entering it correctly, right? Because as soon as they enter it correctly, then we'll have them stop entering it. So sometimes some situation makes sense to flip it and say the opposite. And we'll talk about that in more depth, but yes, that is kind of a confusing symbol. Okay, so instead of doing nested ifs, you saw a program where we had an if, and then we had an if inside the if to do this exact same code. So we had the employed, and then the recent grad was inside of that as a nested if. But instead of doing a nested if, you could do it with an and. You can say if you're employed and your recent grad, because the Y stands for yes. So if those two things are equal to yes, then that means that they're true. Then you qualify for the special interest rate. Otherwise, it's going to give you both things that could be wrong because it doesn't know which one of these was false. So it just says you must be employed and have graduated in the past 2 years to qualify. So if one of these is false, then the else will happen and it'll just tell you this instead. So it doesn't know which one's false, but if it's false, then this C out will happen. But it kind of condenses it. If you wanted to be more specific about it and you wanted to say which one of these happened, like is it that you're not employed or that you're not a recent grad, then you have to do it the other way with the nested ifs. But if you can just condense it into one, then this way is less code. Okay. So this is an example of an or. So if the income is greater than or equal to the minimum income, or the years is greater than the minimum years, then you qualify. So either one of these has to be true, or both of them can be true. But if one of them is true, then you qualify. If both of them are true, you qualify. But if neither of them are true, then it must say you must earn at least whatever the minimum income is, or have been employed for more than a certain number of years. So you have to have one of them be true for it to be true, or both if you want. Okay, so far so good? Okay, so now this is the opposite. We were just talking about this before. So this one actually says the opposite of this. So it flipped them. So if this ends up being true, then it flips it to be false. And then it says it says the other way around. So whatever this comes up being, it ends up being flipped. So if you haven't had an income of greater than or equal to the minimum income, or you haven't had more than the number of years that you have, then it's going to say this. Okay. Otherwise, if you have, then it wouldn't match this and you qualify. So it's just a different way of thinking about it. Takes a minute to kind of think about that though. What's the opposite of that? Okay, does anybody have any questions? All right. So first the not is handled, and then the and the or. We call it short circuit evaluation. So what happens is whenever you have an and you look at the first expression that you're dealing with, if it evaluates to false, it won't bother to do the second expression, because if it's false, then it doesn't matter what the second one is, because it's going to be false. So for example, if I say you need to do your assignment and your quiz, and you didn't do the assignment, if I check, did you do the assignment? And you say no. Well, I don't really need to check if you did the quiz because you didn't do what you were supposed to do. Well, now it depends on how you handle points, but let's say a different example. Maybe I say, in order to take the exam, you need to bring a Scantron and a pencil to class. And I say, did you bring a Scantron? And you say no. well, then you can't take the test, right? It doesn't really matter if you brought a pencil, because if you didn't bring the Scantron, then you can't take it. So there's no point in checking for the pencil. So that's called short circuit evaluation. Now, if you have an or, if I say, okay, to take the test, you need to bring a pencil or a pen. Well, if I ask you, did you bring a pencil, and you say yes, I don't really need to ask you if you brought a pen, because you've satisfied the first one, and it doesn't really matter if you brought both of them or not. You already did the first one. So you don't need to check the second one if the first one's true in an or. And so that's called short circuit. So it doesn't bother to check the rest. Now, if you didn't want to do short circuit evaluation, instead of doing 2 ampersands, you just do 1. And instead of doing the 2 lines for the or, you just do 1 line. So it works if you just do 1. And sometimes certain situations, you want to continue to check the other ones, even though you know that it's going to evaluate to true or false. So if you have a reason for wanting to do that, which as you get into more difficult programs, you may want to do that, then you would use the 1 ampersand or the 1 or. But if you don't have an actual reason for wanting to check all the sides, then you should use both, because it saves time. And there's no point to check the whole expression if you don't have a valid reason for wanting to do that. Does that make sense to everybody? You all following? Okay, you lose anybody yet? Okay, so if you're trying to see if something is between, a lot of times when we're saying a range, we use the word between, but there's no between when you're doing it in C++. So you have to use and. And is between. And so what you do is you have a starting point, and you say, like, for example, if grade is greater than equal to 0 and grade is less than equal to 100. So that gives you a between. It means between 0 and 100, including 0 and 100. So if you didn't want to include 0 and 100, you could take off the equals. Okay. So it depends on what you want to include and what you don't want to include, but you're going to say greater than this and less than this, and that tells you what to include. If you want to include those 2 numbers, then you put the equals on there as well. Okay, so that gives you a between range, okay? Now, you always have to make sure that you repeat grade over here. Like, for example, you can't say if grade is greater than equal to 0 and less than equal to 100, okay? Because it has to know what variable you're comparing to this number here. It doesn't assume that it's still the same first variable. So you have to write it again. That happens a lot when students are doing it. And then if you're trying to do a grade that's invalid, you use or. So like, for example, grade is less than equal to 0 or grade is greater than equal to 100. So if you put like 500, that would be out of range. That would be outside of this. If you put negative number, that would be outside of range. So ors are great for doing invalid things that are out of range. If you were to put or for this first one, for example, for this if grade is greater than equal to 0, if you would put or instead of and you were trying to see if it was between, it wouldn't work because only one of them have to match. So like if you put negative 1,000, that would be less than equal to 100, even though it's not greater than equal to 0. So you have to be careful, because if you accidentally put or for something that's supposed to be between, then it includes any value, because it opens it up to either side. You don't have to have both sides. With an and, both sides have to be true. So it has to be between those values. But with an or, only one side has to be true. And so or works great for invalid, but and is great for anything that you're trying to see if a value falls between a certain number and another number. Okay, and you can't write it like this. I know that that looks nice, but you can't write it like that following notation. Okay. So you can use if-else statements for menus. So if you're trying to get someone to select something, you say like enter, like let's say you're trying to do a calculator. You say, okay, enter an A for addition, or S for subtraction, or you can say enter 1 for addition, 2 for subtraction. You can say like if their choice equals 1, then do this. If their choice equals 2, then do this. Else if their choice equals 3, then do this. Okay, so you can use the if else if structure for doing a menu. Okay. So again, you can come up with enter 1 for this, enter 2 for this, enter 3 for this, and then have them just see if it's equal, if the choice is equal to 1 or the choice is equal to 2 or 3. And then you can make your else if they entered something that isn't one of the choices, and then you can say something like invalid in that particular case. Okay, so you can do input validation. You can check a range to make sure it's inside the range that you want. You can do a menu choices. You can have validation. You don't want them to divide by 0. So you can do like an if to make sure that the second number is not 0. Okay, so here's an example of an invalid one. So you can see you're asking them for a number. You're validating that it's between a certain number. So here, make sure it's between the minimum score and the maximum score. So this between is and, remember? And as long as it's between there, then it's going to check for what letter grade it is. Notice that the else is an F here because you're not going to have invalid because you wouldn't have gone and matched this if you were invalid. So you don't have to put else is invalid here because this if handles that, because if this weren't true, it would have went to this else and said invalid. So you can do it a little differently. Instead of putting an else at the end to do invalid, you can do an if that encompasses all your choices. So these are nested. And the only way to get to these choices is to pass this, is to make this true, because then you go from this curly brace on line 25 to line 37, and all of this is nested. And so if you get past this, if you meet the minimum and maximum score, if you're between those, then you're going to get inside here to see if it's an A, B, C, D, or F. Otherwise, you're going to get on here to the invalid. Okay. So you can use a comparison of characters and strings as well. So when you're comparing characters, it actually uses the ASCII value, and you don't have to memorize this, but capital and lowercase letters are different. So when you're comparing them, they'll be different. So if you do know the ASCII values though, like for example, capital A 65 and capital B is 66. So then when you compare them, you know that B is greater than A. So then it'll evaluate to true or false based on the ASCII values. And so it helps you to compare them. So you can look them up if you need to, but you don't have to memorize them. So you can ask to get a character from the user. Remember, when you get a character from the user, you use cin.get instead of doing the cin, because the spacebar and the enter key will mess up input when you're doing characters and strings. So you want to use the get when you're doing that. So then you can do a comparison. You can see if the character, and you can test to see if it's between 0 and 9, because it'll get the ASCII values and it'll do a comparison for you based on what it brought in. And so then you can see if it's a digit, for example, and if it's between a capital A and a lowercase c, or a capital A and a capital Z, it'll say you entered an uppercase letter. And then if it's between lowercase a and lowercase c, it'll say you entered a lowercase. And then if it can't find any of this, it'll say it's not a digit or a letter. So if you put like a different symbol in there, for example, then it'll tell you it's this else. So with the if, else structure, if one of these is true up here, the if or the else if or this else if, then it won't go to the else. That one will happen. But if none of these are true, then it automatically else happens. So if it doesn't match the digit, the capital, or the lowercase, then of course it has to be some sort of symbol that you put in there. Okay. Any questions? Okay. You can also do strings the same way. So if you had 2 strings, Mary and Mark, and you can compare the 2 names. So is name 1 greater than name 2? It's going to compare all the ASCII values of the different characters. And so they're the same up until you get to the Y and the K. Okay. So it depends on where they are in the alphabet. If the Y is greater than the K, so that's true. And then name 1 is less than or equal to name 2. Well, they're not equal, that's for sure, because there's 2 different characters at the end. But name 1 is going to be greater than name 2, so that's going to be false. And then they're not equal because they're not the same name, so that's true. And then name 1 is less than Mary Jane. Is true, because Mary Jane has more characters. Okay. You can see if something, like for example, this program is checking for parts. And so you can see if a part number is a certain number and you can put the string in there, it'll actually check it. So If it is, it'll say the price of that. If it's this part number, then I'll say that price. And if it's not either of these two parts, then it's going to see it's not a valid part number because those are the only two parts we have. Okay, so it's an example of strings. And there's a fancy way to do if else. If you're just doing a simple if else, and those are the only two options, that either happens or the other one happens, then you can write it like this. You can write your expression here. So for example, x is less than 0. If that's true, you put a question mark here. So this is your if that's true, then this happens. This first part, y equals 10. So it's going to make y equal to 10. If this is not true, then the second part, what's on the other side of the colon, happens. Z is assigned the value of 20. So if this is true, you make y equal to 10. If this is false, you make z equal to 20. It's just a fancy way of writing it. Do you have to write yours like that? No, you can write it as an if else if you wanted to, but you should know enough to know if someone else writes it like that, what's going on and how to evaluate that. But if you don't like that, you don't have to write your code like that. Okay, so we have the different pieces here. We test x is less than 0. If that's true, then we make y equal to 10. If that's false, we make z equal to 20. Okay. You may need to add parentheses depending on what you're doing for your expression. Okay, so here's an example. So we have a pay rate and a minimum hours. How many hours were worked, takes in hours. And then if hours is less than the minimum hours that you need to work, so however many minimum hours is, which is 5. So if hours is less than 5, whatever you enter, then it's going to make the minimum hours as the hours value. And if not, then it's going to make the hours that you entered the hours value. Okay. So, and then it's going to base the charges based on the number of hours that you have. So if this is true, if the hours that you enter is less than 5, then it's going to make it 5 instead. So like, let's say you enter 3. Then it's going to make the minimum hours, which is 5, your hours. So it's going to make it 5 anyways. And then if you enter something that's not less than that, so if you enter 5 or 6, let's say you enter 6, it's going to take 6 and make that your hours. So you're going to get at least 5 hours. But if you enter anything more than that, you'll get the higher number. Does that make sense? Okay. So we can do something called a switch. And anytime you do a switch, you could just use an if else if structure. But some people like to use the switch. Sometimes it's easier to read. And so you should know when you see one what it does. But if you want to use the if else instead, you could. So really, you can choose which one works better for you, but you should know how it works. So when you do a switch, you're going to put your expression, whatever is true or false here. And you have to be working with the same variable. You have to be talking about the same expression. And then when you're talking about the expression, like for example, you might be doing a choice. You might ask the user to enter a choice. And if the switch, you're going to test to see if the choice, and then you're going to have case 1, for example, like if they enter 1, what do you want to do? Maybe we want to do addition in that case. So enter 1 for addition, 2 for subtraction, for example. So you might do switch on the choice and say case 1, and that would be your addition. Case 2 is subtraction. And you can keep having as many choices as you need. And then instead of having an else on the end, just like we do with if, else, if, else, if, else, if, else, you have a default on the end, and that works as your else. So if none of the other ones matched, then the default will happen. So you don't have to have a default. It's optional if you want the default, just like an else is optional. Okay, so here's what it looks like. So enter choice A, B, or C. So then it takes in the choice, and the switch is based on the choice. It has to be the same variable you're working with. So based on the choice, if they entered A, then it'll match you entered A. If they entered B, it'll say you entered B, C. And if it's not A, B, or C, it'll go to the default and say you did not enter A, B, or C. Okay, so in this one, if you enter B, it'll say you entered B. And then this one, if you enter F, it'll say you did not enter A, B, or C. Okay, but you notice one thing on this, you notice that there's a break after all these different cases. The break is important because it tells you that once you match this one, then break out of the switch, go out of the switch and go to the next thing. So go to the end of the curly braces here and start the next thing, which in this case is nothing because it just returns 0. But the break is important because it tells it not to do the rest of the cases. If you don't put a break on there, then it goes and matches the rest of the cases on here. So it doesn't do exactly what you think it would do. So you want to have this thing called a break because that stops it from matching any more cases. Okay. So we need to make sure that we're working with integer values, not decimals, when we're doing our switch. And we don't need to have the default, it's optional, but it is recommended. That would be more like your invalid. Okay. So we have to be careful we put something called a break on there, because if we don't have a break, what happens is it matches whichever one that it should match for the case. And then it goes on to match the other ones as well if you don't have a break. And so that causes problems. So you use the break to exit the switch, so it doesn't do any cases that it shouldn't do. So for this example, there's no break on the 300 and 200, but there's one on the 100. So if you were to match the 300 one, it would actually go and do the 200 and the 100 and then break out. So that's probably not what you want. So for this example here, it asks you if you want to enter 100, 200, 300. If you enter 100, it says remote, this model has the remote control, right? So 100 works because there's a break there. So it says remote control and it breaks. Okay, so you get to enter whatever number you want. And if you enter 100, it seems to work fine. That's because there's a break. But if you enter 200, it says stereo sound and remote control. But if you enter 200, it should just say stereo sound. It shouldn't say remote control because that's the 100. So if you put a break here after the 200, it would only say stereo sound. It wouldn't say remote control. But it depends on if that's what you want. Sometimes that's what you want, because maybe the 300 model comes with all of the following. It comes with the picture-in-picture, stereo sound, and remote control. So if you don't break, then it includes all of those. And so sometimes that's exactly what you want. So maybe if you get the 200 model, it includes the stereo sound and the remote control. Okay, so that might be what you want it to do. But if you didn't want it to include the remote control, then you would put a break here. But it probably makes sense for this program because the higher models get the one that's with it and all of the following. And so this one, if you get the 300 model, then you get all of the options: picture-in-picture, stereo sound, and remote control. So you go back, it gives you all of the options. So if you get 300, you get this one, and this one. So it only breaks after this one. So it really depends on what you're doing, because if you put a break after this one and this one, you wouldn't get all of the following options. And so it's good for this particular example because if you get the higher model, you get this and all the following. And it only, if you get the 100, it breaks after this one. You don't want it, if you don't break after the 100, then you'll get the default as well. And you don't want it to say you can only choose 100, 200, 300 if you chose one of these, because that doesn't make sense. So you do want to make sure you have a break on the 100 because you don't want it to end up in the default, because the default is you're invalid and you only want that to happen if it's invalid. And if you take out the break, it will happen all the time. Okay. And if you say one that's not a model that exists, then it'll say the default. It'll say this, you can choose the 100, 200, or 300. Okay. So in this particular example, it actually makes sense to not have the break on the 300 and 200. But in the other example, you wouldn't want it to say that you entered other letters you didn't enter. So if you didn't have the break here and you entered an A, it would say you entered an A, B, C, and you did not enter A, B, C, or C if you took out the breaks. So that one wouldn't work the way you want it to work. So you do need to make sure there's breaks in there. But for this one, it makes sense to not have the breaks. And so you need to decide if you want it to fall through to the other cases or not. You put the breaks if you don't, and you take the break out if you do. Okay. All right, so the switch daemon works really well for menus. You can see here how it's easy to follow. If you're using the same variable and you're just comparing the variable with different cases, then it's easy for people to follow as a menu structure. And so it's used a lot for menus. Okay, sometimes you'll hear people say that something is out of scope, their scope of variables. And so whenever you're using curly braces, that's a block of code. And whenever you define something in a block of code, it's only good in that block of code. So when you're doing this, for example, you see that on line 21, there's a variable called years that's declared as an integer. It's defined as an integer. Because it was defined inside of this block of code from line 17 down to line 32, the program only knows what this years variable is inside of these curly braces. If you were to come outside these curly braces and you were to ask it to print off the years, it wouldn't know what you're talking about because that's defined inside of the curly braces. So you have to be careful when you're doing it. And you define something inside of a set of curly braces that you don't want it outside of the curly braces. So for example, if you have more code in your program down here that you're going to print something out or you're going to use this years variable, then you don't want to define it inside of the curly braces in here. So what can you do? Well, you can just simply put above this if statement here on line 15, you would declare your years variable. And then when you come out of your curly braces down here, it would know what it is. So if you declare something outside of the set of curly braces, then you're good for whatever curly braces you're in. So if you declare something in your main function in C++ at the top of your main function, then it's good for the whole main function. But if you declare something inside of your if statement, it's only good for that if statement and it doesn't know what it is. It's called scope. So the scope is whatever curly braces, whatever block of code you define it in. So defining it is important. And so you can define it up above and then just use it inside of here and outside of here. Sometimes you don't want it to be available outside of the block of code that you have. And so it makes sense to define it inside of there. But if you want it outside the block of code, then you have to declare it or define it outside of that block of code. Everybody with me? Okay. So inside of the curly braces, they have local, they're local to that block of code. Okay, so if you want it outside that block of code, you have to declare it before that block of code. So this is kind of confusing because in this program, we have a main function that starts at line 5, ends at line 22. And so you can see you have a variable here on line 8 called number. So it's defined as an integer. Number is an integer. And you're taking that in on line 11. Okay, and then you're testing to see if that number is greater than 0. So here, let's say you enter the number 2. Okay, 2 is greater than 0. So it goes inside of here. But then on line 14, you have another variable called number. You can do that because of the scope. So you can have one that is in the outer scope and one in the inner scope block. And when it does it actually sets up 2 different variables with the same name in 2 different memory locations. And it becomes confusing. Okay, so we have 2 different number variables. And then you're asking them to enter another number and you're taking it into number. So this number is getting saved in this number variable that's local to this if. So when you're printing it, it's going to print the one that you enter for the second number. So when you enter 7, it's going to print 7. But when you come out of the if you ask it to print number, it's going to print the original number because we're outside of the if now. So inside of the if, this number would be used. Outside of the if, this first number would be used because they're in 2 different memory locations and they have different scope. So depending on where you are in the program, what set of curly braces you're in, that tells you which one you're using. And so it becomes a little confusing because you're using the same name, but they have different, they're different variables that are saved in different places because they have different scope. So that's a little tricky. Okay, so we'll end with that challenge there on scope of variable. And what I want to do next week is I want to ask you some questions in Kahoot, and I want to take a look at some code. I want to play around with some code, with some if statements and some switch statements and see if everybody understands that. So I want you to make sure that you go through the chapter, see if you have any questions about it, write down your questions, do the exercise for the chapter, see if you're okay with that. And then that way we can answer any questions you might have next week. But does anybody have any questions on this content that was covered today?
No, I don't.
Okay. All right. And I'm sorry for all the confusion as far as classes being canceled. So please check Canvas for your other classes and see what you're supposed to do with the snow day.